Good day. It's Wednesday, July the 28th. I'm Martin Gagel with Market Radius Research. We've got Raveel Afzaal, CEO of NXH Hydrogen, with us today. NXH Hydrogen is a designer and manufacturer of electrolyzers that use water and electricity as inputs to generate clean hydrogen for use as energy source. I've got NXH Hydrogen on the call for a few reasons. I'd just like to sort of explain those as the rationale why we have these companies on. So got the NXH Hydrogen on the call because it's a new listing, so it's a new story to learn about. I was first introduced to it, I think, last December as it was private still. It is in the green tech, green energy space, which is very interesting to me. And as well, it's in the hydrogen space and and I'm very curious on how hydrogen will emerge as part of the new energy economy. So it's great to have you on the call, Raveel. And just to highlight that this is not a recommendation or investment advice. We're here to learn about the company, do your own due diligence, and invest cautiously. So Raveel, thanks a lot for joining us today, and let's hear about NXH Hydrogen.
Martin, thank you so much for having me on your show and the initiative. Really appreciate it. So NXH Hydrogen, we are listed on TSX Venture Exchange under the symbol NXH. The mission of the company is to decarbonize the transportation sector and the industrial sector using green hydrogen, and we want to do it on a global scale. The company itself, it was founded in 2008 by pioneers in the water electrolysis space. What they have been focused on for the last 14 years now is debottlenecking some of the key issues with alkaline electrolyzers and optimizing them for integration with renewable energy resources. The design has 38 patents on it, and it's been validated with Atomic Energy Canada Limited and Canadian Tire. And we recently announced a partnership with Hyundai as well. So let's start with the team. The company, as I mentioned, was co-founded by Dr. Michael Stem and Dr. Jim Hinatsu. They had been building electrolyzers since 1990s. First for Stewart Energy, then for Hydrogenics, and some of your viewers may recall the Hydrogenics was acquired by Cummins. So someone who has been building electrolyzers since 1990s is intimately familiar with what the problems are with the electrolyzers and what needs to be done to debottleneck some of these issues. And that's been the focus, as I mentioned, since 2008. Along with them, we have Matt Fairley, our vice chairman. He was actually the chief technology officer of Stewart Energy. So we have some of the top talent in the hydrogen space at NXH Hydrogen, which is Canada's most advanced electrolysis company today. We have supplemented them with top talent across the board. We have a very strong product delivery team. Initially, we had a world-class technology and product development team, and we wanted to supplement them with top engineering talent, top manufacturing talent, and top aftermarket service teams. And that's what we have done. Jim Davies, our VP Engineering, comes from Doosan. Our VP Manufacturing, Jim Frankwell, comes from GE Healthcare, Delphi Automotive, and others, whereas Shane Day was actually at Stewart Energy and has installed 60 plus hydrogen systems in Ontario. So we are a solutions company with strong product delivery all the way from technology development to aftermarket service support. Complementing that is our board with the likes of Michael Pyle, CEO of Exchange Income, third largest airlines conglomerate here in Canada. Susan, who is the president of Schneider Electric Sustainability Division. JP, VP of Engineering at Google, was previously at Tesla, set up the Gigafactory, also with Lego. And finally, Anthony, who is the outgoing CFO of Ballard Power, and Ballard is the leader in the fuel cell space, so understands the space really well. So I think we have brought on some really high quality independent board members and have grown our team from to 35 folks right now, and is going to grow further from here.
Raveel, sorry, just can you just Schneider Electric? Maybe not a lot of people know how big they are. Can you maybe just they're a big company, right?
Oh, as big as it gets, and most importantly, they are known for integrating different types of technologies together building redundancy in microgrid as well as other electrical systems, and they have a key push towards sustainability. So getting someone like Susan on our board to have her mind share on how to integrate these types of technologies at scale, I think it's super helpful. Schneider is a global player, as you know.
Yeah. All right.
So let's talk about the company. As I mentioned, started in 2008. We
Raveel,
came up with a.
Sorry, I'm going to interrupt you here. I'll interrupt a bit.
I like it.
So you are electrolyzers, and just let's get real simple here. Back in grade 10 science, we put an electrode and a whatchamacallit into some water, and in one test tube was hydrogen and one test tube was oxygen because it broke apart the water, and then we light one of them on fire and it'd go poof. That's what we're basically talking about here, right?
That's right. Breaking the water molecule using electricity, H2O, using electricity. And if you can use green electricity, then the hydrogen that's produced is called green hydrogen. And we have a purpose-built system for green hydrogen production. It's a lot easier to do it in lab, a lot more difficult to do it at scale.
All right, thanks. Continue.
Thank you. Thank you for that clarification, Martin. So we started off in 2008, NXH Hydrogen. The first thing that we did was we did a demonstration with Atomic Energy Canada Limited. Why we worked with them was because they needed high current density electrolyzers. I'll speak a lot about that during this presentation, because high current density basically means using less materials to produce more hydrogen for us. So it's a very key point because that reduces the cost of your equipment. Very successful project. They publicly spoke about how successful that was, and you seldom see such blue chip companies talking about someone's technology and talking about how it performed. And then in 2014, we won a demonstration with Canadian Tire that was looking to decarbonize their distribution centers by moving over from lead acid batteries over to fuel cell forklifts. They selected our technology to fuel their forklifts with a 0.4 megawatt system. We had the system validated by a third party. Following that, Canadian Tire publicly spoke about the success of this project. And eventually, the key part, they gave us orders for 2 systems, both about 1.8 megawatt systems. And that was a transition from a technology company to a manufacturing company, but the capital wasn't there. You know, in the green hydrogen space, the capital really started coming in 2019. And so once, over the last 12 months, we have raised about $64 million. We are moving into our manufacturing facility in September, and we're getting going on scaling up our technology to deliver on these orders. And this is just the beginning. This is our first product line. Expect multiple product lines coming out of NXH Hydrogen in the next 3 years to address this incredible opportunity in front of us to decarbonize transportation and industrial sectors.
Raveel, the Canadian Tire, what did they do with the hydrogen? Was it to run forklifts or trucks, or was there some sort of industrial or heating process? What was the use for it?
Yes, so they are transitioning their forklifts that were previously being powered by lead acid batteries to fuel cells. And what fuel cells do is that they take hydrogen and convert it into electricity. And so these forklifts are going to be powered by hydrogen. And for their distribution centers for material handling application, that's what the start is. And there are multiple distribution centers. Right now, we have orders for 2 distribution centers, but then also outside of distribution centers, they also have gas stations across 401, which is one of the busiest highways for heavy mobility.
All right. So, and then previously, if they wanted to do hydrogen at their distribution centers, they'd have to have a contract with Praxair or one of the big gas guys, have that shipped over. Now they're they're plugged into the grid or solar panels on their roofs, and then they can produce their own hydrogen.
Exactly. So your supply chain becomes a lot more efficient. You don't need cryogenic tanks, which people will tell you is a permitting nightmare, and you don't need to store 10 days of hydrogen on site. So with our solution, you store a day and a half of hydrogen in gaseous form and use it when you need it, and you don't have to worry about supply disruptions, snowstorms, all those different things disrupting your supply chain.
Right. And I guess since you're not moving it or anything, you don't have to have the same high pressure systems that the liquefied gas, or do you still pressurize it like that on site?
Yeah, so you don't need to liquefy it. to transport it, which is very important because it saves you a lot of cost. But still, you do need it to be pressurized to go through the dispensing system. Yes.
All right. Thanks.
So summing up the story for us over here, we have exposure, as Martin just pointed out, forklift market, so material handling market. Then think about the heavy mobility market where you need to go long distances and cannot have lithium-ion batteries that pretty much weigh so much that it's difficult to carry the load that the truck was made for. And then you have the industrial market where you need a gas and cannot electrify those processes. So think about cement, steel, fertilizer. So green hydrogen can be used in a wide variety of markets, and it's estimated that by 2030, this could be an $80 billion market, just water electrolysis equipment alone. And at this time, there are less than 10 notable players in this marketplace. And we are coming with a very unique hook with respect to our product, which has been made, as I mentioned, by pioneers in the water electrolysis space. What our product really does is gives you high current density operations, which means that the systems are compact and can also cost less, because high current density, as I pointed out, essentially means you're using less materials in the electrolysis equipment to produce more hydrogen. So that gives you a cost advantage as a customer. Number two is our dynamic response. We can ramp the systems up when the sun is shining and ramp the systems down when there's cloud cover a lot quicker than our peers, which allows you to better capture the renewable energy resource. And we're talking about alkaline electrolyzers over here. Point three.
Raveel, sorry. You're essentially you're an energy storage system. Instead of having a battery, you have a windmill, or for load leveling kind of situations, or solar power. You've got excess energy, you turn it into hydrogen, and then when at nighttime or whatever, when you don't have the power source, then you can use that. So it's basically another type of battery storage system.
Absolutely. I mean, you would tip, and with respect to hydrogen, it can be stored a lot longer compared to what you'll get with a battery. Yes, and essentially you want to tap into those arbitrage opportunities where you have surplus energy available, or when the prices come down substantially. But in some cases, people are operating them 24/7 as well, because when you use them for ammonia production or something else, these are 24/7 operations where you need it in downstream processes.
All right.
Okay, so then the final point being inherent scalability. We can make these systems very, very big using our unique design, which gives you economies of scale. So together, those three things: high current density operations, meaning you're using a lot less materials; dynamic response, meaning that you're capturing the full renewable energy resource; and inherent scalability, which gives you economies of scale. Together, that are three very distinct features of our alkaline electrolyzers, which represents a very promising path to reducing the cost of these electrolyzers and making green hydrogen more economical to be used in multiple industries. What the target is for us and for the industry is to bring green hydrogen to the cost of diesel by 2030, if not sooner. And as we talked about, we have substantial patents on our design. We have 38 patents. Currently, we're commercializing our 123 megawatt product line, but we are now well capitalized with $55.5 million recent raise. And we have multiple products that we want to bring to the marketplace, including much larger electrolyzers, which can be used for utility scale applications. Finally, very excited that we are publicly listed now. We are the only pure play water electrolysis company that's giving investors exposure to this $80 billion market by 2030 alone, and exponentially rising in North America. And I would have said fourth one globally, but there was another company that just recently got listed. So fifth company globally. The two markets that we service. One is the green hydrogen market. So over here, what you'll have is electrolyzers, which are directly tied to wind farms or solar farms, producing green hydrogen in large quantities. And then in a regional model or a distributed hub and spoke model, you have that hydrogen transported over to industrial customers or transportation customers that have captive fleets. Then for smaller on-site applications, the system is typically, as Martin pointed out, connected to the grid behind the customer's fence, typically 1 megawatt, 2 megawatt systems, and used to fuel forklifts, or captive fleet that the customer may have. So these are the two big markets for us on the transportation space and then in the industrial space. We started off with Canadian Tire because if you want to be in the on-site market and are a Canadian company, we think there's no better customer than Canadian Tire as your flagship customer. We have 2 orders with them, both for 1.8 megawatt systems, and we are scaling up our technology to deliver on those. And just to put this in perspective, a 1.8 megawatt system, this will produce about 650 kilograms of hydrogen per day. That's sufficient to power about 200 forklifts twice a day. So it's quite a large system and can really help decarbonize some of the distribution centers. Moving on, we also recently announced our partnership with Hyundai. So Martin, when we spoke in December, what I talked about was over the course of the next year and a half, what you'll see is increasing partnerships, strategic partnerships by NXH Hydrogen. And what type of partnerships do we want? We want partnerships with customers that can bring an end market to us. That can be a go-to partner for us. That can scale up our engineering and manufacturing. And the first one we delivered on is Hyundai and Kia. They looked at alkaline electrolyzers, they looked at PEM electrolyzers, the whole space, and in the end decided to go with our technology. Why? Because of our high current density operations, which, as I pointed out, can help reduce the cost of electrolysis and make green hydrogen more economical. As part of this partnership, we are bringing our IP, our unique design. They are bringing the supply chain, and we are going to deliver them a new electrolyzer, proof of concept electrolyzer in Q2 22. And then following that, it's also going to involve commercial discussions with our organization.
So if, let's say, this is successful and it moves forward, would they be essentially, let's say, a manufacturing partner for these systems in Asia, presumably? Or would they, because I believe they're both fairly substantial fuel cell players. Is that where they're kind of looking into sort of, they have the fuel cell and the hydrogen production system? How does it sort of integrate with these two very large businesses?
Yeah, so it's at this time, it's difficult for us to speak to that just because we are in those commercial discussions with them and they're confidential.
Okay.
So it makes it difficult for us to speak about this. But one point that I should mention over here is Europe just recently said that they are banning fossil fuel cars and transportation applications by 2035. Just think the impact that's going to have in terms of infrastructure that's going to be required on the hydrogen fueling side. And what companies are looking to do is offering a full solution, which includes infrastructure, which includes transportation mediums as part of that. And we think Hyundai is one of the key, Hyundai and Kia are leaders in this space. People can Google what they're doing in the hydrogen space and you'll see their hydrogen fuel cell powered trucks that they are bringing to the marketplace. And they're not the only one. Daimler is doing it. BMW is doing it. Hyzon, a recently publicly listed company, they are doing it. So it's a very big market and you need to be in front of this transportation market. And this is our first foray into this with a transportation company. And our hope is that we can deliver strategic partnerships over the next 12 months with multiple other household names, which will bring end market to us.
All right.
Okay, so what do we deliver? We deliver a full solution, comes in containers that can be delivered to the customer site and is a plug-and-play system with water purification all the way to hydrogen production. I'll speak to this slide in a second. Let's talk about our IP. What have we done differently? Very simply, you talked about what is hydrogen, how is hydrogen produced? You basically break the water molecule and into hydrogen and oxygen, and you'll typically have an electrolyte in it, KOH. So what you do is in a typical system, when the hydrogen is produced and the oxygen is produced and the electrolyte is dragged in to these small pipes, and then through that electrolyzer module, the hydrogen and the electrolyte goes through the length of the electrolyzer to these external gas liquid separators where hydrogen and electrolyte are separated, and then that electrolyte is sent all the way back to the electrolyzer to replenish the cells for that reaction to keep happening. That's design has been around since 1930s, 1950s. So all the big improvements we have seen since that time have been in terms of cell materials, cell components. But what we did was we looked at that overall infrastructure design and we said, we focused on decentralizing that fluid and gas flow separation. So in our case, instead of the centralized external gas liquid separation, we are separating the gases and the liquids right on top of each cell plate. And when you do that, you unlock the potential of these electrolyzers through these three key distinct features. One is you can pass a lot more current through the system without getting these choke points in the manifolds or the small pipes running the length of the electrolyzer, carrying the liquids and the gases through them. You unlock that potential. So you can pass a lot more current through it. And what we are talking about is current densities of 2 to 2.5 times higher than our peers. If you hear that in the lithium ion battery world, that someone has 2 times higher current density, I mean, it's quite a big statement. And that's what we're doing in the hydrogen space. And we have demonstrated that through 2 pilots. And as I pointed out, this can result in significantly lower cost for electrolyzer equipment. And number 2 is that because of the way we are separating fluids and gases inside the electrolyzer in a decentralized fashion, our system is super responsive, resulting in the improvements that I talked about in better capturing the renewable energy resource. And finally, because of the same feature again, you can make these systems a lot bigger. And just to put this in perspective, our 2 megawatt system, what we're working on right now versus our 6 megawatt system, our 6 megawatt system is only about 50% bigger in terms of footprint compared to a 2 megawatt system. So that should give you some sense of the economies of scale that you get, that you're getting 3 times greater output with only 50% increase in output. So those are the 3 distinct features that we have with our unique design to reduce the cost of green hydrogen and make it economical and at parity with diesel this decade.
So Raveel, a couple of can you go back to that slide? So essentially what you're saying with 2.5 times the current density, your equipment can be less than half the size of, like crudely speaking, less than half the size of the current equipment and maybe less than half the cost, and take as much power in to convert as much, to create as much hydrogen. Is that kind of roughly how it is?
Exactly right. So
okay.
Exactly right. Our equipment cost will be about 50% lower. It should be theoretically about 50% lower on the electrolyzer module. Balance of plant is balance of plant. You know, that is not impacted by this innovation. But because you're passing a lot more current through the system, your energy efficiency will be slightly lower. Right now, just like think about a car that's going at 400 kilometers an hour versus a car going at 50 kilometers an hour, right? So the car that's going a lot higher will consume more, will be less energy efficient compared to someone that's going at 20, 30. But what you're saving on the upfront capex will more than offset the relatively lower energy efficiency at this time. But the second thing to also note is engines are improving. By that, I mean the cell materials, cell components are improving. So someone who can run a lot faster is going to disproportionately benefit from all these new innovations that are coming through in the cell materials, cell components. And finally, renewable, like typically where you want to use hydrogen systems is where renewable energy prices are low to begin with, or you have surplus energy available. So our system was made for this market, which has finally come alive. And think about our co-founders who have been working on this for almost 14 years. So you must have real conviction behind your design to stay in this market. And finally, it's coming to fruition. We have a product which meets a well-defined market need. And kudos to them for the persistence and the conviction behind their design.
You also get economy, or you gain efficiencies as you get bigger. So what you're saying is that if you want to get twice as big a system, it's not a modular system, you just replicate it. You actually design a bigger one that is more efficient and cheaper. So you get economies of scale or efficiencies of scale out of the system, right?
Exactly. Because the thing is that when you start making a conventional system bigger, you start running into those fluid flow restrictions that I talked about, fluid gas flow restrictions that I was talking about. Because the way we have decentralized fluid and gas flow, we don't have those types of restrictions, which allows us to make these systems really big without thinking about it just on a modular basis, adding two megawatt systems and putting 5 of them together. No, with our design, you can just have one system, which is about 10 megawatts, so to speak. 9 megawatts is the size we're going for. and it'll be one system. And that's where you start getting real economies of scale.
And just, it just kind of dawned on me, you are sort of the anti or the opposite of a fuel cell, where a fuel cell takes hydrogen and then creates power and its output is water, and then, but you take the water and then create the hydrogen. So you're kind of like an electric motor versus a generator, but sort of different technologies, right?
Exactly. We are the reverse of fuel cells. Fuel cells need hydrogen to convert into electricity, and we provide the hydrogen. So exactly right. But when you think about fuel cell companies, we have two applications. You can use hydrogen both through a fuel cell and converting it into electricity for transportation applications. That's one use of hydrogen. But then you can just use it purely as a gas in industrial applications where you cannot electrify them because electric furnaces just cannot burn hot enough. And so you need a gas. And if you're not going to use natural gas, then hydrogen is the answer. So hydrogen that we generate can be put through fuel cells for motive applications or just used directly as a gas.
And does any of your technology may be applicable to the fuel cell as well? Like, I presume creating those bonds and breaking them is kind of different. But is any of your technology applicable in any other spaces or in the fuel cell space?
It's complementary to fuel cells, but it's not directly applicable. So it doesn't mean that because we can build electrolyzers, we can easily build fuel cells. No, that's not the answer, but it's super complementary. If you have fuel cells, you need hydrogen, and our system will provide you with that clean hydrogen that you need.
I'm curious, if you, let's say, have 1 megawatt of electricity, and then you convert that to hydrogen through your system, and then you take that hydrogen through a fuel cell and put it back to electricity. How efficient is that? If you start off with 1 megawatt, do you end up with 800 kilowatts, or do you get what I'm getting at?
Oh, totally. I mean, depends on the type of applications you have. In some cases, the energy efficiency could be 60%. In some cases, it could be 70%. And this is really changing at this time. It's not these numbers vary from application to application, but it's not definitely as energy efficient as using a battery. So at this time, if you use an electric battery, for sure, it's more energy efficient in terms of taking it and then putting it back into the system. But what about the types of applications where you cannot use batteries? So think about heavy mobility. If heavy mobility applications, you have a lithium-ion battery in there, and you want to go a long distance. If you want to go a long distance, then you'll have to have a much bigger lithium-ion battery, and these batteries weigh a ton. And so that's one of the key issues that you'll run into, that you cannot go the full distance without having a very heavy lithium-ion battery, which reduces the amount of load that the truck can carry. And then another thing to think about is asset utilization rate, because you and I both know there's nothing that kills margins than poor asset utilization rates. And if you have to park something for even say 45 minutes, or in other cases 3 hours, because these are trucks and buses that we're talking about, you have a serious issue over there. And with us, it fuels just like you would do with a gasoline car. And so you really save on that asset utilization. And final thing I'd mention is there's a reason why NASA uses fuel cells, because it can withstand harsh environments. So you will not get the degradation of performance that you can get with batteries.
And what you're implying there with the batteries versus the hydrogen and with fuel cell is the energy density in hydrogen is way bigger than it is in battery technology. So a truck can pile way more kilometers on it, so to speak, than it can with a lithium or with whatever battery technology.
Exactly, and with a lot less weight. So what you'll see is in the future, well, the future is almost here. What you'll see is hydrogen cylinders on top of these trucks. The hydrogen will go to a fuel cell. The fuel cell will take that hydrogen, convert it into electricity. You'll still have a lithium-ion battery, but a smaller lithium-ion battery. And it'll continue to charge that lithium-ion battery in real time, allowing you to go much longer distances. Think about it as a battery extender. We are not we are not here to fight the batteries. We love batteries. We are complementary to the batteries. We extend the life of batteries in mobility applications. But then, in other forms, you just use it as a gas, where the round trip, to your point, will be a lot more even better.
So it's almost like there's the hybrid cars between an internal combustion engine with the lithium battery to sort of give it the range extender. But now you can do that with the lithium battery and a hydrogen fuel cell, and it's sort of a hybrid battery fuel cell system.
That's the future. That's exactly what's happening in the space.
All right, cool.
Awesome. Our patents, we have 38 patents, as I mentioned, but I'll just highlight our 2008 patent. You see connection of water electrolyzers to wind farms. So as I mentioned, there's a lot of attention being paid to green hydrogen right now. We have been focused on this market for a very long period of time, and we've been thinking about how to optimize our systems for that. And those are the key characteristics that I was talking about with respect to our technology for this green hydrogen market, which is coming in a big way. And why is it coming in a big way? Number one is, I think the life of fossil fuels is getting limited, especially in certain applications. And wherever you can decarbonize those applications, I think fossil fuels are eventually getting phased out, like we are seeing in Europe with 2035, a ban on fossil fuels in transportation applications. And why is that important, right? Fossil fuels are the leading contributor to carbon emissions, and carbon emissions lead to global warming, which leads to the types of things that we are seeing, which is flooding, wildfires, and accelerated rate of ice being melting. So, these are things, visible climate change impacts that are visible for all to see. Unfortunately, I think this decade is going to be about, getting our game up and fighting the climate change challenges that are in front of us at this time. So we have to step up now, and the governments are stepping up, and now the private sector has started to step up. And why green hydrogen is getting a lot of traction is also because there's a very visible path for it to approach cost parity with diesel. And by the way, I don't even know if that's the right benchmark to use, because by 2035, I don't know if diesel is going to be around in as many applications as we see right now. It will certainly be around, but not in all applications that we see today. So the reason why green hydrogen is getting so much traction is because 80% of our cost is renewable electricity prices. And there was a time when renewable electricity prices were 12 cents. Now you're seeing contracts being bid at about 4 cents. And then you have the surplus electricity that's available for almost no cost. Second is, go ahead, Martin, go ahead.
Sure. I'm just thinking, like, in terms of energy transportation, let's say if you're in Mexico or New Mexico or Texas or something, you could have sort of a hydrogen fuel station, but it's connected to windmills and solar power. So it's sort of its own refinery oil system. It's a self-fund or self-fueling gas station, except it's with hydrogen. And then that sort of cleans up the supply chain. You don't have to worry about grids getting knocked down or pipelines being shut down because of cyber criminals or whatever that's been happening over the last year.
I think hydrogen could be exactly a great answer for decentralized solutions. The market is still changing, so we don't know exactly how it will pan out. I think
it's like the cryptocurrency of energy.
Well, a lot more quantifiable in this case.
Yeah.
I think the fundamental value over here is very easy to understand. When you think about how I think this market will pan out in the transportation, it's already gaining a lot of traction. Initially, where it's going to be is going to be captive fleets. So, because it's otherwise it's going to be a chicken and egg problem in the light vehicles. Hey, do you have the infrastructure? Do you have fueling stations across the block? No, I can't buy light vehicles. But in the heavy mobility space, where you have 200 heavy mobility vehicles or 400, then you have your own gas stations, right? And in that case, you can have the hydrogen gas station over there and producing hydrogen on site. In other cases, what you might see is a regional model where it's still not those hundreds of miles where hydrogen is being transported, but think about 50 miles. You have wind farms over there, you have hydrogen being produced at those wind farms, and then in a small distributed hub and spoke model, think 50 kilometers, the hydrogen is being transported over to these places using, the hydrogen being produced using electrolysis, being transported over to these fueling stations or industrial customers that need a clean gas. And some people are talking about actually shipping it across oceans, because ammonia is a very cheap carrier, right, of hydrogen. So using ammonia as a carrier to take it across oceans, and you're seeing plans in Australia because of Australia's unique characteristics to take that hydrogen in the form of ammonia and bring it to areas like countries like Japan.
Sorry, I was going to bring up ammonia later, so since you brought it up, like, sort of explain hydrogen and ammonia, how ammonia is a cheap carrier of hydrogen, because with like one of the biggest polluters in the world are like freighters in the ocean transportation, which is used bunker fuel and diesel, which is pretty nasty stuff. And they're talking about fueling those with ammonia. And so with hydrogen, you can sort of efficiently produce ammonia, which could be another fuel itself.
Yes, so well, I mean, yeah, they can be ammonia fuel cells, right? So fuel cells that can just use ammonia as it is. But the way to think about it is like the number of molecules that different things can carry, right? So ammonia can carry more molecules of hydrogen. So the formula is NH3. So it can carry 3 molecules of hydrogen, and so it becomes a cheap carrier that way into across shipping routes. So that's what they mean when they talk about using ammonia as a carrier, because the molecule itself, it carries a lot more hydrogen, allows you to carry a lot more hydrogen across oceans cheaply. But that's one application. And the second one is just using ammonia, like think about the fertilizer industry, right? In the fertilizer industry, you need hydrogen. Typically at this time, hydrogen is produced using steam methane reformation, where you take natural gas and steam and you produce hydrogen. In that industry, instead of this natural gas powered hydrogen generated from natural gas, you can just produce hydrogen using electrolysis and feed it into the fertilizer process, which already uses hydrogen, and now you're using a cleaner form of hydrogen. So there's 2 ways of using it. And yes, there are discussions about ammonia fuel cells, where instead of pure hydrogen, you can just pass ammonia through it. But that's those are the, I mean, you will see a lot of interesting derivatives coming out for the use of hydrogen and how to transport it over the next over this decade.
Is there any use for because you produce hydrogen and oxygen, is there anything you can really do with it? Like if it's remote oxygen, you just gas it off and the world can use a little more oxygen? Or are there any sort of value coming out of that?
Yeah, I mean, oxygen can be used for ozone treatment. You know, ozone treatment is quite a well understood disinfectant that can be used for disinfecting things in the agricultural space. Also, it has medical applications. But really, it's about oxygen is, of course, not valued highly enough to transport it over long distances and make money on it or do it economically. So it depends on where the system is placed. Now, in the case of, think about a wastewater facility, if the hydrogen is produced over there and the hydrogen goes to a nearby busing station, and then you can take that oxygen for a water treatment, that would make a lot of sense. So such models are being explored, where you can, instead of gassing it like it's mostly done at this time, they can be used for water treatment, ozone treatment, for disinfecting purposes, medical applications, all of those different varieties.
All right, thank you.
Okay, so we were talking about what makes hydrogen cheap. One is 80% of the cost is renewable energy pricing, and the second one being the decrease in the electrolysis equipment. It's down about 50%, 40% over the last 5 years. We see line of sight of bringing it down by about 50% in the next 5 years. And as a result, like as green hydrogen becomes more economical and you see that price approaching cost parity with diesel, you will start seeing a wide variety of applications. We talked about the transportation and we talked about the industrial applications, but the key point being industry experts are forecasting that 1/4 of all energy consumption by 2050 could be hydrogen. And this is already happening today, because a lot of people think that, hey, is this going to happen after 5 years, 10 years? No, it's happening today. And look at the mandates that have been put in place. And this is not just one region, it's global. You count up all of these mandates, it's pointing to about 100 gigawatts of electrolysis capacity by 2030. And it's exponentially rising after that. I'll let your viewers see this at a later time. But this 100 gigawatts, what that really implies is a 80 billion US market by 2030. And as I pointed out, there are less than 10 notable players in this space. And we are coming with a very unique product to produce green hydrogen into this market. And that is, and you can see from the other chart, the global hydrogen production scenario, 2030 is just the beginning. This market is expected to really start taking off even after that. So this is not a 5-year play. This is at least a 30-year play. And finally, water electrolysis is just one part of the component. You can get exposure to multiple different complementary adjacent verticals to really grow your TAM.
And just on the fuel cell side, like so much news and publicity has been around the electric battery car with Tesla and so forth. But companies like Toyota and I believe the Korean companies, they've had continued to have, and we've got like here in Vancouver, like Ballard and Loop Energy, and there's still a lot of focus on hydrogen fuel cells, and some of the biggest car companies in the world have still, I believe GM still has a decent focus on the fuel cell world. Is that correct?
Okay. Absolutely right. I mean, almost all the major car companies now have a hydrogen program underway, but most of these programs, I think near term, I mean, if you ask me over the next 5 years, where hydrogen makes the most amount of sense in the transportation space will be in the forklifts, material handling space, and number 2 will be in heavy mobility, because you don't have the necessary infrastructure to see those light vehicles really taking off and seeing that widespread adoption. After that, it's yes, for sure, you'll start seeing more and more light vehicles getting using hydrogen. But where it makes the most amount of economic sense at this time is on the heavy mobility side. If you want to go long distances and you want to have a light truck so you can actually carry the load that the truck was made for and gas it up quickly so that you can have higher asset utilization, it's starting to make a lot of sense to use hydrogen, and that's a huge market in itself.
All right, thanks.
Talked about the number of players in this marketplace. You talked about fuel cell companies. As you can see, there are many, many, many fuel cell companies, very few notable electrolysis companies, and even fewer publicly listed pure play electrolysis companies, and we are one of them. And what we are bringing is a very unique product, as we talked about. You know, there's 2 types of electrolyzers right now. One are the PEM electrolyzers, which have a polymer electrolyte, and the other ones are alkaline electrolyzers, the one we are bringing to this marketplace right now. So what the advantage of the alkaline electrolyzers is that they're cheaper and much more durable. So last about 90,000 hours versus PEM around 60,000 hours. So those are the 2 advantages of alkaline. But what we have done is we have looked at some of the best features of PEM electrolyzers and incorporated them into our design with much more cheaper and durable alkaline cells. And those ones being the high dynamic response, higher current density. So we are trying to give our customers the best of both worlds: cheaper, durable systems with some functionalities that you would expect from PEM. Probably not at the same level. Our current density is not at the same level as PEM, but it's 2 to 2.5 times higher than what you'll get with a typical alkaline system using much more cheaper, durable cells. And then the dynamic response is very good as well, comparable to PEM.
Do you have any other inputs besides electricity and and water, or like, or is your I don't know, the catalyst or whatever, does that get fully recycled, or do you have to sort of top it up a little bit?
It has to be topped up so that the agent that you're talking about is KOH, and yes, it is. You have to top it up, but for the most part, it's being recycled again and again. It's very small volumes of KOH being added to it.
And the systems are very sort of independent. You don't need a guy there tweaking knobs and sort of maintaining it. It can just run self-sufficient without a lot of maintenance.
Yeah, exactly. And you will have remote monitoring on it, of course. And I mean, this is not something new, right? Electrolyzers have been around since 1930s. One of the biggest one is in Norway. So they have been used for a very long period of time. It's a well understood technology. Hydrogen is a safe fuel. You know, it's already used in wide quantities around the world. But how do you make these electrolyzers come with the times? Because these old electrolyzers that were there, they were made for steady electric current, low operating points or low current densities, producing a set amount of hydrogen that's used in the downstream process. But the world we have moved into is intermittent energy, intermittent renewable energy. So you need these systems to become a lot more responsive to that. And that's where our innovation really comes in.
All right.
So these are some of our targets. We have exposure to a very large market opportunity. We want to be a top player in the hydrogen market. How we are going to do that is through securing very high quality household names, strategic partners that will bring an end market to us. Hyundai is a good example of that. We want to show more over the next 4 or 5 years. We want, in the next 1 year, we want to have 4 to 5 new partners, strategic partners, and we are talking about in the transportation space, in the industrial space, on the manufacturing side, as to demonstrate what an opportunity it can be for us. Our gross margin targets are in the 30 to 35% range, and with EBITDA margins of 20% longer term for us. So that's the focus right now. We are moving into our team is well built out. We are moving into our manufacturing facility in September. Our ERP system went live this month. We want to do 5 demonstrations with strategic partners, as I pointed out, which bring an end market to us, and that should position us for 2023, where we want to get into large volume commercial sales. And no, for us, the ticket size could be, one order could be $20 million. So it's not like fuel cells, which very small orders, right? Like one RFP could be a 20 megawatts order. So revenues can ramp up very quickly in our space, especially when the market is growing as quickly as it is.
With going back to that and your margins and revenues and so forth, do you have any sense of how much scale you need to have? And then as well with the pricing of your electrolyzers, I'm sort of thinking let's say with solar cells, the market's been booming, but then sort of the cost curve has been going down and it's super competitive. Do you have any sense or indicators of like what kind of price points you could have? It's priced on the value you're giving, and you're competing with, sorry, I'm thinking out loud here, you're competing with other energy sources as well as other electrolyzer companies. I've thrown out a lot there. Could you sort of talk about sort of pricing and scale on the economies of scale for your facility?
Yes, I mean, we think the electrolyzer prices are going to come down, and that's being baked into our forecast. Like what we want to do, I mean, some of the smaller electrolyzers right now can cost you up to about 2,000 euros per kilowatt, and as with some of the other ones, it's about 1 million per megawatt. So just giving you some range, and the larger systems are going to be slightly less than that. What our focus is to bring the price closer to about $300 per kilowatt by 2025. That's what we're aiming. And how you should think about a distinct competitive advantage. And by the way, we wish everyone well, because to decarbonize our planet, we all need to collaborate and work together to make that happen. But the way to think about us is you can have 2 electrolyzer companies. In our case, if one company can operate at 2 times higher current density, then it should always be able to use less materials to produce the same amount of hydrogen, and that should give it a sustained cost advantage over its peers, because it can operate at 2 times the higher current density. So that's how you should be thinking about what keeps our margins together and what keeps our competitive positioning together. So I'll quantify that. Typical alkaline electrolyzers operate at about 500 milliamps per centimeter square. Our electrolyzers, we expect to operate at about 1 amp per centimeter square, and going higher over the next 5 years to further not sustain, expand that competitive advantage that we have.
All right.
And then you should think about supply chain optimization. When you're one of 10 notable players in the electrolyzer space, you of course will get a lot of interest from manufacturing partners, and you want to capitalize on them as these opportunities come to establish a very low cost supply chain base, complement that with your significant technology advantages, then you have a story to tell.
Would there be any opportunities sort of to get higher margin, is like license out the technology? So you license it out to big XYZ company in Europe or Asia, and they just give you a couple of bucks per whatever, and then you don't have to worry about, you run on an asset light model?
Very good opportunities in that space. It's a proven business model, and we're just keeping our head down right now and working through all of these types of potential opportunities. And through these strategic partnerships, I think it's definitely a possibility that you might see that.
But I guess also you want to run your own manufacturing facilities, so you have hands-on experience, know how to do it, and then you've got more IP that you can transfer and presumably capture value and margin for.
Totally. We have only committed to building one manufacturing facility right now, which we're moving into in September, as I pointed out. This is going to be a cookie cutter type of a facility, which can be replicated by whoever we partner up with, or if we want to do it ourselves or do it in a low cost jurisdiction or license it out. You need to show how it's going to work. And once you can show how it works, that opens up all these different types of business models that you're referring to, but you got to show it first.
All right.
So that brings us to the end of our presentation. The final two things I'll mention is very clean capital structure, about $50 million of cash on the balance sheet, no debt, 25 million shares, roughly 26 million shares outstanding, with insider ownership about just below 25%. So very strong stake by insiders and a management team in the company, and a very clean balance sheet. So that brings us to the end. I mean, very large market opportunity. We are pioneers in the space. We are coming with a very unique product into the marketplace to address the incredible needs to decarbonize transportation and industrial sectors. This is just the beginning for us with our 1, 2, 3 megawatt product line. Expect a lot of new products coming out over the next 3 years. And finally, strategic partnerships and demonstrations with them in 2022 will continue to show multiple pathways of commercialization for NXH Hydrogen. And with that, I'll turn it back to you, Martin. Thank you.
All right. Can you just flip back to your balance sheet there, or we can just talk about it. We don't need to see the balance sheet. You've, from what I saw, 50 million of cash on the asset side.
That's right. So it's slightly more than that. Let me just get to that slide. And then we have paid down $5 million of debt. So we had $51.2 million of cash, and then we had some debt on the balance sheet that we paid down from our raise. And so right now we have about $67 million, or $300,000 worth of debt, roughly, on the balance sheet. That's really it.
And your cash on hand, how far, what kind of runway does that get you? It lets you build your facility, I'm guessing, and sort of how long do you have until you have to come back to the market? I guess I'm asking.
I should say 2 years. If we keep running very, very hard, but of course, if we need to slow down, we can slow down. But 2 years is is what we bought through this last financing.
Gotcha. And I'm just noticing you've got the deferred revenue there. So someone's paid you some upfront money was that for systems or kind of R&D work, or are you doing contract type work for some of your partner clients?
It's Canadian Tire. So Canadian Tire paid for the system. That we with them, the 1.8 megawatt system that we talked about. So that's the revenue that you see over there.
All right. Okay. That's great. Thanks.
Thank you. So.
Well, you talked about a lot of, on the last slide there, you don't need to bring it up, that you've got some other sort of expected news flow coming, without obviously giving details, but what kind, is it more partnerships, new product launches? What kind of news flow should people be generally expecting?
Yes, so demonstrations and strategic partnerships, and you ideally want both of them together. So demonstration with a potential strategic partner, similar to what you saw with Hyundai. With Hyundai, we're demonstrating a proof of concept unit, and then hopefully a scaled up version of that. And that's what we're trying to do over here with other partners and other verticals that are of interest to us.
All right, and you also mentioned on that last slide new product launches. Are those basically bigger, better, more efficient electrolyzers, or is there some other kind of applications or other types of things we'd maybe be surprised about? Oh, look, this new thing that you guys are doing.
Yeah, no, right now it's bigger and cheaper.
Okay.
And the reason why bigger is important is because if you want to do large scale hydrogen production, you need bigger systems. And what you really save on is the balance of plant, because you don't need one balance of plant. You can rationalize a balance of plant for a much larger system. The balance of plant becomes a much lower cost compared to what it would be for a smaller system. So you start getting balance of plant rationalization costs as well with larger systems.
Okay, we're almost into an hour on this, and you've been very patient with all my questions, which I appreciate. Are there any sort of, let's wrap this up, and any sort of closing comments or closing statements you'd like to make before we close it up?
Martin, I think you asked really good questions, and I think you covered everything that I want to speak about. Thank you so much for having us as a guest on your presentation, and hopefully we can do our part in decarbonizing our planet. We are driven by higher intentions. I can tell you that with a heart on my hand, a hand on my heart, like we are going to work really hard to decarbonize our planet, and we want to collaborate with all folks that want to join us on this mission.
All right, Raveel, that's great. And hopefully we can get you back maybe in a couple of months after some of your partnerships and new products and whatever get launched, and we can get a bit of an update as to how you guys are progressing.
Thank you so much. Thank you, Martin. Thank you for having us.
All right, Raveel, thanks a lot, and we'll talk to you again soon, hopefully. Cheers.